Hey, my wonderful students, Jock here, and it's time to do our day 32 video on momentum, impulse, and how to tell the difference. So I'm going to give you a brief review about momentum and impulse and the system, and then I'm going to show you a really neat way of organizing your thoughts, and then we're going to execute it on a problem that's kind of tough. So the quick review, the major ideas. First of all, we have impulse. We know it's the change in momentum of an object. The symbol is delta P. It's in Newton seconds or kilogram meters per second. Again, this is the change of momentum of an object, just one thing. Then we have momentum. It's the amount of motion an object has. It's just P, not delta P, in the same units. And then we talked a lot about an isolated system. Remember, this is a system where there's no external or outside forces acting on the things we defined as in the system. In an isolated system, the system momentum, or the total momentum of everything added up, before and after, has got to be the same. That's the phrase conserved. And because of that, the change in momentum, which is called the impulse, of each object is equal and opposite. If you hit me, the amount of momentum you gain or lose is equal to the amount of momentum that I gain or lose. So if you punch me and you slow down, then I speed up. The momentum of how much you slow down equals the momentum of how much I sped up. So here's what I want you to do. I want you to have your notebook open to hopefully a big, full, empty page. We're going to do a kind of, not a concept map, but like a flow chart together. So start off by writing this at the top. There is a collision, impact, or force. Since that's true, we ask ourselves, is there a graph? And hopefully this is the middle, because on the left-hand side you're going to have a lot of stuff, and the right-hand side you're going to have a lot of stuff as well. So then ask yourself, is there a graph? If it's yes, then we ask, what is on the y-axis? I need more room. So here we are. What is on the y-axis? If it's force, we're going to use the impulse as the force times time to get the impulse. And we read the force directly off the graph. However, if instead it says velocity, we're going to use impulse as the final minus the initial momentum, where the final momentum is mass times the final velocity, and initial momentum is mass times initial velocity to get the impulse. We can find the final initial velocity from the sloped region of the graph itself. So if you have a graph, you look at the y-axis. If it's force, we use this relationship to get the impulse. If it's velocity, we use this relationship, which involves velocity, to get the impulse. If it's force, we just look at directly on the graph and say, oh, looks like the line's around 25 newtons. That's our force. For VF and VI, we have to look at where it begins and ends its slope. So now we'll go back to this question. We're here again. Is there a graph? On the left-hand side, you have this. On the right-hand side, however, is underneath the word it says no. You're going to write, is your goal velocity, mass, or force time? Again, need more room. If your goal is to find a velocity, we're going to use the table strategy like I taught you in class to find the system momentum and then use that to find what you need. That's usually true for mass as well. But if your goal is force and time, we have to find the impulse from the final minus the initial momentum, which might have to use a table as well. But then we have another step of using impulse equals force times time to find the force or the time. So with that, you kind of have a little way to like judge problems. You start looking at it. Is there a collision? Okay, then there's all these different things that could happen. So I want you to write down this question. Leave a bunch of space for it as well. I'll read it off to you as well. You can always pause when you need to. An atomic nucleus at rest decays, that means breaks apart, into an alpha particle and a smaller nucleus. What will the speed of the recoiling nucleus be if the alpha particle is going 3.8 times 10 to the 5th meters per second? Assume the smaller nucleus is 57 times as big as the alpha particle. Ooh. Okay, let's go through sentence by sentence. An atomic nucleus at rest, so you underline at rest, decays, breaks apart. Okay, so this is a momentum situation where one thing becomes two. So before, there's an alpha particle and a small nucleus together. Each one's at rest. So the total system momentum is going to be 0, we're going to say soon. What will the speed of the recoiling? Okay, underline speed, that's velocity. And recoiling, that means that they're breaking apart and going opposite ways. If the alpha particle is going that many times meters per second, assume the smaller nucleus is 57 times as big as the alpha particle. Okay. Here's your chart you're going to make. Object 1, Object 2, System, MVP, MVP. We don't know the masses, so let's call the alpha particle is mass m. We can do that. That means that the other particle is going to have 57 times it, or 57 m, as its mass. However, both are at rest because they're both together, And so the total momentum of both of them and the system is 0. If you're a little unsure what I'm doing here, you go look at your template problems we did right before Thanksgiving, and this is the third one. So here we have a little system. System momentum is 0. It's the same afterward because there's nothing external happening here. The decay happened between the two particles. There's nothing outside the system affecting it. They have the same mass after. We know object 1 is this speed. We're trying to find object 2 speed. So here we go. I have the momentums. So what I'm going to do is I'm going to say that the momentum of object 1 plus momentum of object 2 equals the system momentum. The m's cancel, which is always very nice. And I'm going to end up getting the velocity of the recoiling, which makes sense. It's negative because it's going backwards, because this one's positive, it's going forward. And since this one's very light, it's going so much faster than this one. In fact, if you're really smart, this one, because it's 57 times lighter, is going 57 times faster than the heavier one. How much impulse is there on the alpha particle if it's 2 times 10 to the minus 4th kilograms? Okay, we're trying to find impulse. We could either use the force and time or the mass times change of velocity. We know nothing about force and time, so we use the mass times change of velocity. Now we're looking at just at the alpha particle, so let's only use the alpha particle's information, which is, I believe, object 1. Impulse is final minus initial. We know the mass, we now know the final velocity, we know the initial stuff is 0, so we get 76. Now this is not realistic, because every time, 76 is a lot of impulse. In reality, this mass is super, super tiny, but I just want to kind of show you a basic example and not make the math too loco. So we did a problem, we made a flow chart, and we're pretty decent now. This video is a good review of what momentum and impulse is. Have a great day.